Okay, so we all know light is fast, right? I mean, it's the fastest thing in the universe. But have you ever stopped to think about why it has a speed limit? It feels like it should just be infinitely fast, but it's not. And the reason why is, well, it's not really a rule for light at all. It's a fundamental law of reality itself.
So, yeah, why is there a cosmic speed limit? And what would happen if we could just, break it, punch it past that limit? The answers are honestly way stranger and a lot more profound than you might think. All right, first things first, let's talk numbers. In a perfect vacuum, light clocks in at exactly 299,792 kilometers per second. Yeah, we usually round it up to 300,000 because it's easier to say. But that super precise number, that's a universal constant. It's not a suggestion, it's not a guideline, it's the law. And just to give you a sense of how insanely fast that is, imagine this, a single beam of light could zip around the entire Earth more than 7 times in 1 second. Blink, and it's already done it. It's just a mind-boggling speed.
But here's the thing. The raw speed, that's not even the weirdest part of this whole story. Not by a long shot. What's really fascinating is where this speed limit actually comes from.
Because here's the big reveal. The speed of light isn't really a property of light. It's a fundamental property of the universe itself. It's a rule that's literally woven into the fabric of space and time.
Okay, and this is where your brain might start to hurt a little, in a good way. It doesn't matter what you're doing. Standing still, light moves at 299,792 kilometers per second. Racing in a super-fast spaceship, same speed. What if the flashlight you're holding is moving? Doesn't matter. Everyone, everywhere, no matter how they're moving, measures the speed of light as exactly the same. It just never changes.
So how can we wrap our heads around this? Well, try thinking of the universe like a giant cosmic game engine. Like in a video game. Every game engine has built-in rules, a sort of physics engine that defines what you can and can't do. In our reality, that engine is what we call spacetime. It's this 4-dimensional fabric that weaves space and time together into one thing. And just like that video game, our spacetime has its own set of absolutely unbreakable rules.
And here it is, the biggest rule in the entire cosmic playbook. The speed of light isn't really the speed of light, it's the speed of causality. It is the absolute maximum speed that cause and effect can travel through the universe. It's the speed of information.
So think about what that means. If you could go faster than light, you could break cause and effect. You could literally see a glass shatter on the floor before it was dropped. An effect could happen before its cause. Time would stop making sense. The whole logical structure of the universe would just completely unravel. In short, reality would break.
Okay, so that explains why the universe has this rule. It protects reality itself. But what's the actual physical barrier? What stops something with mass, like us or a spaceship, from just hitting the accelerator and reaching that speed?
Well, this is where Einstein comes in, and things get really, really weird. As an object with mass gets closer and closer to the speed of light, some bizarre stuff starts to happen. First, its mass starts to increase. At the same time itself starts to slow down for that object, and space in front of it actually begins to compress. So as that mass gets heavier and heavier, you need to pump in more and more energy just to speed it up a little bit more. And to get that final push to actually reach the speed of light, the amount of energy you'd need would be infinite. And since there's no infinite energy credit card in the universe, it's just physically impossible.
Okay, but hang on a second. I can hear some of you thinking, what about when light goes through glass or water? It slows down, right? So are we just breaking this unbreakable cosmic law all the time without even realizing it?
It's a great question, but the answer is a very clever no. See, the individual photon of light never actually slows down. When it's traveling through something like glass, it's basically playing a game of tag with the atoms. It gets absorbed by an atom, then re-emitted, then absorbed again. This whole process creates a delay, which gives us the illusion that the light has slowed down. But in the tiny empty spaces between atoms, it's always traveling at top speed. The universal speed limit remains unbroken. So when you really think about it, this speed limit isn't a restriction at all. It's not a bug in the system. It's a fundamental feature. It's what makes our entire universe possible and stable.
Because causality has a speed limit, everything we know can exist. Stars can form and shine. Atoms can hold together. Time can flow in one consistent direction, forward. The universe can remain stable and predictable. This one number, this one rule, holds everything together. Without it, you just have chaos.
So maybe we should stop thinking of it as light being limited. Instead, think of it this way. The universe is perfectly calibrated. It's precisely fast enough for reality to work.
So after all that, what's the big takeaway? What's the one thing you should remember?
Well, the next time you just flick on a light switch, take a second and think about what you're seeing. You're not just making a room brighter. You're watching the fundamental speed limit of reality in action. You're seeing the maximum pace at which the universe itself can operate. And honestly, that's a pretty incredible thought.